And we're rolling.
Okay, so let's start off talking about question number, or problem number 12. Okay?
Woo!
You like that one?
I like that. Well, no, I don't like it, but I like that we're going over it.
Okay. So here's your setup on number 12, right? So you've got two charges, A and B, right? And the only thing you know is that you're going to split this charge at 25 nanocoulombs. You're not explicitly told. I say you're okay.
I'm very hot. We were dancing. I have thick hair. It's a problem.
Okay.
It
You're the next. Okay.
it is rough.
So you know that the charge on A plus the charge on B has to add up to 25 nanocoulombs. Okay, so now you can't solve it that way because you have two unknowns with one equation, right? Now, you're also told that when the two beads are placed 5 centimeters apart, the force between them, what are the charges Q and K? So here's the deal. So then you've got to use F equals K, charge on A, charge on B divided by D squared. So they gave you the magnitude of the force, right? So you've got that 5.4 times 10 to the negative fourth, okay? You know how far apart they are, 5 centimeters, change that into meters, so you got this number. You've got K. Now, but here's the setup. Now you have two equations with two variables. So at this point, solve this for one of these. Okay, it really doesn't make any difference. Solve it for QA. Oh, okay. So the charge on A is going to be 25 nanocoulombs minus the charge of B. So now you can go, oh, okay, F is going to equal K. 25 nanocoulombs minus the charge on B. Charge times the charge on B divided by D squared. So at that point, now you have one equation in terms of one variable. Now, this is where the algebra gets weird because, look, yeah, so you got to end up using the quadratic formula. Okay? So yeah, so you got to distribute that, change the nanocoulombs into coulombs, change the distance into that, and go from there. So yeah, it just turns into a fairly nasty quadratic formula. That's all.
So the answers are not multiples of 5.
Yes, the answers on 12 are both multiples of 5.
Oh. Okay then.
Yes, your answers on number 12 are both multiples of 5.
Does it matter which one is QA and QB now?
No, you don't know.
Okay.
You just know what the two charges are.
The thing about science is we never know.
Well,
We didn't
B plus or
do
minus.
you
quadratic
do
equations.
know what actually on the videos.
Back it out.
Now, let's talk about number 15, because 15 is going to be important in terms of...
Thank you so much.
Many praises among brethren.
Okay, what he showed is actually
But I somehow
what I first.
Okay,
Can I dunk 'em?
so
It's awful.
here's the setup on this one.
It's awful.
So here's Q1, right?
Which he,
And they're separated by, what, 10 centimeters, and then you've
1.5
got
and 10 to make it 16.
a negative 2 nanocoulomb charge, and then you've got another 10 centimeters, and then you've got Q2. Okay? And so on this one, you're told that Q2 experiences no net electric force. What's the charge on Q1? Okay? So here's what you want to look at. So let's just say, if you look at what has to happen, you're going to find the net force. Your net force is going to add up to equal to 0, right? So here's the deal. So let's just say that, number one, you've got these distances. So if you were to, let's assume that Q is a positive value, okay? Let's just say Q is a positive value, okay? So if Q is positive, then you can calculate the force, right? Would that be an attractive or repulsive force that that negative two nanocoulombs is going to feel? Attractive or repulsive? Attractive, right? Okay? So that's going to tend to pull that one that way. So then, if you look at then what's going to happen on Q2, because the whole key to this is that you want Q2 to experience no net electric force, okay? So if this is positive, this is going to pull this one. So then in terms of this force, if Q is positive, that's also going to tend to pull that one in that direction. So if this Q is positive here, then it's going to be pulled in this direction. But if this Q is positive here, then that force there has to push it in the opposite direction. So if Q1 is positive, the only way this can feel no net electric effect is if Q2 is also positive, because it would be pulled towards this negative one, and then it would be repulsed by this one. Now, the whole key to this is that it's KQ1, Q2 over distance squared, right? So, since this, you want this to feel no net electric effect. So, or no net electric force, excuse me. So if this one is positive, this one would also have to be positive, right? But because it's twice as far as that 2 nanocoulomb is, it's twice as far, but D is squared, what has to be the charge on Q1?
Double. 4 times.
4 times greater because of the fact that it's D squared, because it's an inverse square relationship, okay?
Oh.
So if you assume Q2 is positive, okay, that means it's going to have an attractive pole towards the negative, but then it's going to have a repulsive charge going this way, okay? But because of the fact that it's D squared, it's got to be 8 times greater than the 2 nanocoulomb is, okay? Cool with this. Now you say, well, maybe I want that to be a negative value. Okay, fine. Let's make that a negative value. So if you reset the stage and you make that be a negative value, so then it's going to be repulsed by the negative nanocoulombs. So it's going to tend to drive it that way. But so then what charge would Q have to have over here to balance that out? It also be positive. So here's the cool thing about this problem. No matter if you make Q1 negative or positive, Q2 has to be a positive value, okay? So it doesn't make any difference how you define Q1. Q2 has to be a positive value because it's either going to repulse or attract to balance out that other force, okay? Good with that. Okay, now let's talk about 17. So on 17, that's a cool one, mainly because of the fact that you kind of get introduced to this relative masses of these electrons and protons. So on 17, basically you're going to use F equals ma, okay? That's what you're going to do. So you're going to use F equals ma. You're going to find the force divided either by the mass of the proton or the mass of the electron, okay? And so and you should see obviously the electron, which is a lot smaller, is going to have a much more, or is much greater acceleration than the proton does because of the fact that it has a much smaller mass. Now, on that supplemental problem, okay, and you could either work it at the beginning or work it at the end. Don't work it halfway through. That's just going to annoy me. So, first thing you're going to do is that you're going to calculate that force, and then you can compare that to the gravitational force. So you got to go old school to calculate that gravitational force. Got to use F equals big G m1 m2 over d squared. And then you're going to compare the value, the relative amount of force. So what you should see if B goes right, you should see that over that same distance that force is 10 to the 10th times greater. Right?
That's gonna be.
Wait, are we talking about which one? We're talking about the problem.
The supplemental problem that I typed up,
Okay, so I just used LibOG.
huh?
I just used
Yeah, I thought it
LibOG.
meant the earth, not the beads on each other, but like the earth on the beads.
No,
So,
Yeah,
No.
that should have been specified.
I didn't say towards the earth.
It, well, usually it's assumed.
so we gotta use G, you only know G.
So
Let's just
on
do-
C, that acceleration should be around 30 meters per second squared,
I actually got an answer like that.
What was it?
around 30. Now, make sure on problem number 16 out of the book that there's a couple of things that you need to specify on 16, okay? It says, what's the magnitude and the direction of the electric force on each? So you need to specify both of those. Is it, you can say, is it up, is it down, left, right, positive Y, negative Y, something like that, okay? Just somehow specify it. Just don't say, oh, here's the force. So make sure that you've done both of those. And on number 10 out of the book, that force should be something times 10 to the negative fourth. And your acceleration should be between 5 and 10 meters per second squared.
Yeah, apparently, so, yeah, it only affects speed. So.
Why didn't I write down the units?
Hmm?
Why didn't I write down the units in here? Just wrote down the number. Maybe.
Okay, so
G.
it's camera still going? Up.